All right, I'm going to start anyway. We got a related rate problem. This is out of section 3.9, page 203. All right. Man starts walking north at 4 feet per second from point P. 5 minutes later, a woman starts walking south at 5 feet per second from point 500 feet east of point P. What's the rate at which the people are moving apart? So I need a good figure. You have point P. A man starts walking north. All right, he's moving at 4 feet per second. And I'm going to call this, I don't know, I'm going to call this Y. All right, that distance is going to be Y. Then a woman starts walking south from a point 500 feet east. And she's going to walk south at 5 feet per second. And I'm going to call this Y1, I guess. All right? So I got Y going up and Y1 going down. At what rate are the people moving apart? 15 minutes after the woman starts walking. All right? So this guy gets a 5-minute head start, and then 15 minutes later. All right? So guys, do we agree? We got to take times 15. We're going to have a 15-minute walk here. How long is the man going to get to walk? 20 minutes, because he had a 5-minute head start. We got to build this triangle. We got to build this triangle. And here's what I see. I simplified this diagram. I can make a triangle out of it where this is 500 feet. This is Y plus Y1. And this is the distance between them at any given instant. And again, we don't have to use a variable for the 500 feet because that's a fixed distance. Y and Y1, we have to use those variables. So we can always write an equation based on our figure, all right? D squared is equal to Y plus Y1 squared plus 500 squared. All right? Now, we got to go back and say, what is the 4 feet per second?
Huh? What?
What is the 4 feet per second?
That's right.
Oh, that's dy dt.
That's dy dt. So we have dy dt is 4 feet per second. And then obviously 5 is dy1 dt, related rates, 5 feet per second. All right. That's going to help me when I take the derivatives here. We also need to know, for this case, at the 20-minute instant, what are the distances? Well, this is 500 feet. All right. I have to do for 20 minutes at 4 feet per second. So I have to take what? 4 times 1,200? Did you guys get 4,800 feet for the man? Yeah. All right.
I got 80.
I got 80.
Ah.
You have to take 20 minutes.
20 minutes
and
in seconds.
You gotta have
Second.
It's feet per second, and you're in minutes. 15 minutes times 60 is going to be 900 times 5, so you got 4,500 for the guy. So, I think at the instant, 20 minutes later,
Okay, so that was my
it's going to be 9,300 feet this way, 500 feet this way. Those are my distances at that point, but I can't use them until I've taken the derivative. You guys remember the trick is, if you're trying to find, so we take the derivative, 2 d dd dt, because it's a related rate, we're doing implicit differentiation. I'm going to do, and I'll slide this over, I don't have enough room. I'm going to do this as a chain rule, 2 y plus y1, and then the derivative of y plus y1 is dy dt plus dy1 dt. All right. And then what's the derivative of 500 squared?
0.
0, because it's a number. All right. So we now have the derivative, and since every term, both sides has a 2, we can cancel the 2's right now, can't we? I need to know d. I know y1. I know all the variables except dd. I have to calculate d up here, right?
D is 9313.4.
9313. 0.4 feet. And that's because 9,300 squared plus 500 squared, take the square root of. All right, so now it's simply plugging in numbers. 93, 14.4 feet dt equals y1 plus y2, we know is 9,300. And it's what Caitlin did say. Guys, if it's going 4 feet up and 5 feet down, their separation is 9 feet. They are both positive, even though they're in opposite directions of each other, aren't they?
Yeah.
And this is feet, and this is feet. So the feet are going to cancel, and you're going to be left with feet per second. So you take 9,300 times 9 divided by 9,313, and you get a related rate of what? 1 point
It's just 0.11
times 9 then.
I took 9,300
Times 9
times 9, and I took
divided by 9,313. It's got to be above it. It's got to be close to 9, right?
yeah.
Because 9,300 over 9,313.
Okay, it's 8.98.
8.98. 71 feet per second. And that's the answer, because you got to go 4 decimal places on the AP. And does it make sense that it's really close to 9?
Yes.
Sure does, because when they're going that pace per second, this 500 becomes less and less significant. The further apart they get, the less significant the 500 is. And eventually, with a little bit of time, the distance between them is going to approach the speed they walk apart, right? All right? And the shorter the distance between them, the sooner you would get there. All right?
Jordan, I hope it's okay. I took another one of your little